Scientists recently have discovered a genetic link between cancer and, surprisingly, autism. I'm Mike Mason, a deputy science editor here at the Times. Gina Collada writes about the finding in Tuesday's Science Times, and she joins me today to tell us more about it. Hi, Gina.
Hi, Mike.
So, I think a lot of viewers will be surprised by this. Were researchers surprised?
They absolutely were surprised. I mean, one of the first people to look at this was a woman named Charis Ang at the Cleveland Clinic. And she said, you know what, it seems like an awful lot of these kids have autism. It's like, you know what, was that just a coincidence or what? And that led her and then others on a search saying that people with this particular mutation, this P10 mutation, tend to have autism. And it turned out that they had like about 10% chance of getting autism, which is huge.
That's a really high rate,
huge.
Right?
And then they found then people around the same time started noticing that another well-known gene mutation called tuberous sclerosis, or TS, there's two genes that can be mutated, and half of those kids had autism, which was gigantic.
So just to be clear, we're not saying that what they found is that people with autism are more likely to go on to develop cancer. What they have found is that in a subset of the population with these mutations, there are extraordinarily high rates of autism.
And these are mutations that also provide a risk of cancer. Mm-hmm. And in the case of tuberous sclerosis, they also have a very high risk of all sorts of benign tumors, including ones on your brain that can be lethal if you don't treat them.
So your story tells us that with this finding, scientists have managed to breed a mouse model of autism, which just the phrase alone makes me want to stop and marvel. Like, you know, a mouse model of autism.
Right.
What do they see in these mice, and why do they think it's a valid model?
It's weird. They took one of the genes that we were sort of discussing, and they put it only in the mouse's cerebellum, part of its brain. Mm-hmm. And the mice were sort of weird. They, for example, preferred a plastic. They didn't care if they had a plastic cup or a live mouse to play with.
You know, most mice prefer.
They always prefer the live
other
one.
Mice,
other mice,
okay.
A normal mouse, never. If they had a real mouse, they're not going to go near that cup. Mm-hmm. But these mice, they didn't care. A cup was the same as a mouse to them. Mm-hmm. And they also had this repetitive behavior. They would groom themselves until they were sore and bleeding. It was like, you know, a lot of times kids with autism will have these repetitive behaviors. They kind of can't stop flapping their arms or something. These mice couldn't stop sort of grooming and grooming and grooming. Also, children with autism often have severe learning disabilities. These mice had learning disabilities.
You were telling us that they also are experimenting with therapies.
Right. They took a drug, rapamycin, that's used to treat, that actually attacks this tuberous sclerosis mutation. And they gave it to the mice. And weirdly enough, while the mice were developing, they got better. I mean, they started liking live mice instead of cups, and they could learn where that platform was, and they stopped the repetitive grooming. So the researchers were amazed, because not only did they have a mouse that looked like it had autism, but they had a drug that seemed to make a difference. I
was surprised to read in your story that some of the families with children who are discovered to have one of these mutations and are also autistic, instead of being horrified by this, we're sort of relieved. And it's partly because I guess autistic families with autistic children have struggled for so long to get anything definitive out of the scientific community that's helpful. Did these families feel like this was actually?
One of them said we had an honest-to-God genetic diagnosis. We knew what was happening. You know, there was a reason why this had happened to their kid. And they also found out that the parents didn't have that mutation. It had arisen just in their kid, just by chance. So that also meant that it wasn't like they were going to pass it on to any other kids. But they just wanted a reason. And the other person that I spoke to in my story said, yeah, it was just such a relief to get a diagnosis, to know what really went wrong.
Yeah, so many of these families are dealing with uncertainties around the condition.
That's right.
Well, thanks for being with us today.
Thank
That's
you,
amazing
Mike.
stuff.
Thanks.